Greetings from Maryland. I'm bringing NASA into your home today as I tell you some of the fascinating ways in which NASA satellites are able to measure various things about our environment, including how much precipitation is falling. My name is Dorian Janney, and I am the Education and Outreach Specialist for the Global Precipitation Measurement Mission. I also work with the GLOBE program, and I'm a GLOBE Master Trainer, and I'm also a campaign coordinator for the GLOBE Mission Mosquito. I wanted to bring NASA into your home today as I show you an easy online activity that you can do. But I wanted to start off by showing you how many of us in the GLOBE program, and also with a citizen science group called CocoRaws, measure precipitation that's falling in our own front or backyards. So what I have here is a rain gauge. With my rain gauge, I check it once a day. Usually I check mine in the morning around 8:30 or 9 a.m. and I find out how much precipitation has fallen within the past 24 hours. I'm going to need two hands for this. So I'm going to take the top off, and here I have my tube that's inside, and basically this is just giving me a measurement of the height of how much precipitation fell in the last 24 hours. We've had a lot of rain. As a matter of fact, here I have over ½ an inch of precipitation. In this case, my gauge is measuring precipitation in inches. We also have them that measure precipitation in millimeters. So I actually have 0.55, a little over ½ an inch, and I can show you that when I pour this into the rain gauge, and if we were just measuring it from the height there, you would see that it is a little more than ½ an inch. But we use this inner tube as kind of a zoom lens to help us be able to see more accurately how much precipitation has fallen. All right, let's go inside now, out of the rain, and I'm going to show you how you can use your computer and online resources to find out how much the Global Precipitation Measurement Mission measured in your back or front yard anytime over the past 2 decades. Well, it was really nice to welcome you to my yard to get a chance to see my rain gauge and how I use my rain gauge to be able to measure precipitation from the ground. There are also GLOBE schools all over the world that are using the GLOBE precipitation protocols and a rain gauge to be able to measure how much precipitation is falling in their schoolyards or in their own yards. And as I mentioned, the CocoRaws program is a group of citizen scientists in the United States and Canada who are also using rain gauges and reporting in on their data in order to give us a better understanding and also keep those of us who are interested in doing this aware of how much precipitation is falling in our yards. And of course, precipitation is hugely important, not only because it can mean the difference between your grass growing or not growing, but also because it largely provides us with the freshwater resources that we need, not only to have fresh water to drink, which I enjoy drinking my fresh water all the time, but also to water our plants and to even create energy. So, I'm going to be focusing on the Global Precipitation Measurement Mission, telling you more about that, and the GPM Core Observatory. So there are over 24 Earth-observing satellites that NASA has that are in low Earth orbit, each covering the Earth about 16 times a day and collecting different environmental data, such as air temperature, soil moisture, cloud cover, and precipitation that's falling from the clouds. So here is the Global Precipitation Measurement Core Observatory. Global Precipitation Measurement Mission is an international partnership which is led by NASA and JAXA, the Japanese Space Exploration Agency. GPM was launched in 2014, and it was a follow-up to the Tropical Rainfall Measurement Mission, also known as TRMM, which launched in 1997 and was in operation until 2015. The GPM Core Observatory is about the size of a school bus or a fire truck, and it was mostly built at Goddard Space Flight Center in Greenbelt, Maryland. It flies at about 407 kilometers above the Earth, which is about the equivalent of 253 miles. Now I'm going to tell you a little bit about the two main instruments that are on board the GPM Core Observatory. The two main instruments are the DPR, or Dual Frequency Precipitation Radar, which works kind of like a CAT scan and gives us a detailed three-dimensional measurement of the precipitation structures and rates. It uses both active and passive radar. The GMI is the GPM Microwave Imager. It uses 13 channels, and it helps to measure the intensity of the microwave radiation that's being emitted from the atmosphere, and that allows scientists to be able to calculate the precipitation rates as well as to quantify the intensity and the amount of precipitation that's falling all over the world. All right, now I'm going to show you how we're able to get an updated measurement of precipitation pretty much all over the world every 3 hours. So the GPM mission is pretty special. It's actually an international constellation of satellites. Through bilateral agreements with either NASA or JAXA, GPM achieves global coverage and updates the data every 3 hours, as we're kind of seeing here, because there are existing satellite programs and some new mission opportunities from its partners. Each constellation member may have its own unique scientific objectives that it's working on, but they contribute microwave measurements to GPM, and that is used to give us these global precipitation products. These include satellites from the Department of Defense, NOAA, the France and Indian Space Research Organization, and the European Organization for Meteorological Satellites. So as you can see, this is truly an international collaboration. Now I'm going to show you something that I think is pretty magical. Here we're going to be taking a look at last week's precipitation data. You can see the last 7 days of data anytime by simply going to the Global Precipitation Measurement website. You will note that the key down at the bottom, and I'll come over here and point to that, is showing us that what we're seeing here are the precipitation rate in millimeters per hour. And we can tell if it's liquid. So over here, when we're looking at these kind of green and red colors, that's telling us the liquid precipitation rate. And over here, where we're seeing the blue and purple colors, that's telling us if it's frozen precipitation, snow, sleet, or hail. So let's take a look at this again. Where do you see the most precipitation falling last week? Note, so you can see it looks like we can watch these bands over here that have heavy precipitation kind of over here in Southeast Asia, down here coming into Africa, and over here coming off of, here's where I live in Maryland. So we've had lots and lots of precipitation, done a really great job of watering my trees for Arbor Day and watering my grass and flowers for Earth Day. Where do you note that rain doesn't appear to be falling? Do you see some areas where you're not seeing any precipitation? So you might note around here, and there were a few more locations where they really do not get very much precipitation. Another thing that I think is fascinating as you're watching this data is that you can be seeing the way in which the global wind patterns are operating. You can see that the global wind patterns are blowing the clouds and thus the precipitation from west to east in both the northern hemisphere and also down in the southern hemisphere. But then note here at the equator, it's actually moving in the opposite direction from east to west. So you can see here how this conveyor belt of the global wind patterns carries the precipitation from one location to the other. What we're looking at here is called iMerge data, and that's what we're going to be working with pretty soon. That means that basically it's what we call a level 3 data product, and it has been intercollaborated, merged, and interpolated with all the different satellite microwave precipitation measurements that we got from those other satellites that are in our constellation, and often even some precipitation gauge analyses that are from ground-based rain gauges. So this is a really nice final product, particularly when you're using the final iMerge data, and that's what we're going to be working with. And we're going to be looking at it to get a better understanding of monthly precipitation patterns. So we're going to be working with this activity called From Satellite to Your Backyard, and I'm going to show you how you can find this activity right there on that website, gpm.nasa.gov/education. This has all of the directions that you're going to need to be taking you through how you can generate this information and better understand how much precipitation is falling and has fallen anytime over the past 20 years using both the data from the TRMM mission and the GPM mission. So I'm going to start by just showing you, here's a world map, and there's about where I am in Maryland. Now, to do this, to be able to access the data, you're going to want to go to the Giovanni website. This is a free website. It is a good idea if you're going to work with this data and you want to be able to download data to go ahead and log in and get a free account. Otherwise, you can continue, but you're going to have more limited access than you're going to have if you use an account that you have set up. So once you're in here, and again, don't worry about memorizing this, all of these directions are in that activity, and you've got even hyperlinks in that online activity to be able to follow. But basically what you're going to be doing is you're going to come over to time series, and we're going to look at seasonal. I'm going to start off by showing you seasonal as in, winter, summer, spring, and fall. And then we're actually going to even look at some monthly data. And I'll tell you why I chose seasonal data to begin with. We can look at this data, like I say, for any time over the past two decades. So I have over here that I want the iMerge final in my keyword. I like to kind of put that in first because then that helps to limit some of these other things. I put in that I want from 2000 to 2019. We do have about a 2.5 month delay in this final data product, this level 3 iMerge product that I like to work with. So you won't be able to get the data until about 2.5 to 3 months after right now, because in order to put together those different satellite data, make it a nice clean product and include some of those rain gauge data, it takes a little while to do that. So again, I picked the iMerge final, and then this is kind of the magic of this. I told you you're going to be able to see it in your backyard. Now there actually is a 10-kilometer swath that GPM is measuring, and sometimes it can be raining in your backyard, and then across the street it's not raining or snowing. So this isn't going to be exact, but it is certainly going to characterize the general amount of precipitation that's falling. So over here I put in my longitude and latitude. I don't know why it has to do it in that order, and I have that in the notes, but you're going to be finding your decimal, longitude, and latitude, and then you just stick it in there. You just stick it in one time, so I put in minus 77.196.3 or 196, and then I put a comma, and then I put in 39.2538. You don't have to be, you don't have to go 10 digits, but I just, so that's what I put in there. And now that knows where to be looking for this data. And again, I decided that I wanted to have seasonal, and then after I put this information in, I put plot data. Then, depending on how much data you want and how fast your bandwidth connection is, it is going to generate your data. So that we wouldn't have to wait, I went ahead and got my graph to show you. So at first, this is a crazy looking graph. I chose inches, and so that's what's being displayed over here from 1 to 8 inches. I selected inches because that's what my rain gauge is measuring in, and that way I also like to compare and contrast it to my local airport, which is in inches where I live. But you can set it to inches or to millimeters. Just be sure for making these graphs that you set it to either millimeters per month or inches per month. So here I'm looking for my location at inches per month, and I chose from looking at this for just about the past 20 years, from 2000 to 2000, and I guess I go to 18 here. Now, this looks kind of crazy. Here's what we're seeing. This blue line here is showing us pretty much the winter, December, January, and February. Where I live, some of that is falling as snow, some of it is, of course, falling as rain. What we're looking at, though, is liquid equivalence. So if it is snow, I let it melt in my rain gauge, and then I measure how much the liquid was. And so we can see here, as we're looking at this over the years, that where I live in Maryland, we have a very variable amount of precipitation that falls really throughout the seasons. And that's going to be important when I compare and contrast this to some other locations. So my black line, that's showing me the spring, March, April, and May. And so you can see, often we have more precipitation, and generally where I live, that is in the form of being a liquid. So then our summer, that's always liquid where I live, maybe some hail sometimes, but you can see that, there's some years where we get a lot of precipitation in the summer. So where this dot is here, this is showing me that in 2006, we got about 5.5 inches in that 3-month period. Usually where I live, we have gotten about 43 inches of precipitation per year. We are starting to see that that amount is changing, which is very interesting, and another reason why I like to keep track of that. And then, of course, this is showing us the fall, the fall for the hemisphere that I live in, September, October, and November, and look at the variability there. Pretty interesting to see that, let's say over here in 2007, less than 3 inches of precipitation fell throughout the fall, that 3-month period. But over here in 2011, we had about over 6 inches of precipitation that fell. And you can see over here a large amount of precipitation, and that's in the summer. We did experience a lot of flooding during that time, which is another thing that I just find really interesting about being able to look at this data from a seasonal perspective. So I wanted to show you some of this data from some other locations. Here, we're looking at a location in the South Sudan. And some of you may know, if you've learned about South Sudan, that they have suffered from a lot of problems with famine. And a lot of that is because they've had a lot of drought. So of course, with drought, we're talking about not enough precipitation. Now, if you look over here, again, this is in inches. My other graph for Maryland was going up to 6, 7, 8 inches falling in that 3-month period. Now here with this graph, we're going from 0 to 1.2 inches falling in those 3-month periods. Now, if you take a look here, when do you notice that in this area of the South Sudan, which season do they appear to get most of their precipitation, or more than most locate, more than they usually do? And so you might note that it is in their winter time. So December, January and February, and again, that's pretty variable. But let's see over here in 2006, they got almost an inch, but again, that's in a 3-month period. Over here in 2008, they got about an inch, but look, there was from about 2010 through 2016 when they did not get very much rain at all. And that is what was primarily responsible for the drought, which of course makes sense. A drought is talking about a situation in which you do not have much precipitation. And here we certainly can see that. I wanted to show you some other examples. So here is a location in India, And this is over here in Southeast Asia, they experience something called monsoons. Now, monsoons are where you have a lot of precipitation during certain months of the year and not very much precipitation during other months. And we certainly see that to be true. Look at the summer months there, and now look at the scale. Here we're going from 0 to 50 inches falling in that 3-month period. How amazing is that compared and contrasted to what we were seeing in the South Sudan? So you notice here that, some years, of course, there's a lot more precipitation than others, but we see there's clearly a dry season during December, January, and February, where that blue line is, and clearly a very wet season during their monsoon season in the summer. I wanted to give you an example of some of the GPM measurement data. So here we see in 2017, from July through September, there were extremely heavy monsoon rains. Unfortunately, it resulted in the deaths of many, many people and destroyed lots and lots of homes. What this stresses to us is how important it is to know how much precipitation is falling so that the government officials and the public health officials can be prepared for these extreme events. Here in the United States, we sometimes are impacted by hurricanes. I'm going to show you a little bit of data for Houston, Texas, where Hurricane Harvey impacted us. So take a look here. Now again, we're looking from 2001 to 2018. Where do you see during the summer months, which usually, well, our hurricane season is from June 1st to November 1st. So you're looking at this summer data. Which year do you note that we had, that in Houston, they had an extreme amount of precipitation? And so you're probably looking here and saying, oh, well, that's easy. Look, right over there in 2017. And you can also kind of see here, a different pattern of precipitation than we certainly saw in the last 2 locations we were looking at. That's another interesting thing about precipitation and, of course, about climate. Location, location, location. That's what it's all about. Here's our GPM data looking at Hurricane Harvey in August of 2017. So as it moved through the Gulf of Mexico and stalled over Texas, it ended up dropping about 40 inches of rainfall, and that was, just in a day or two. Unfortunately, that resulted in 125 or more billion dollars worth of damage, and lots and lots of flooding, and unfortunately some deaths as well. Down here, we can see, as we're looking at this GPM data, and we looked at this earlier with the iMerge data, we can see that up near the top of the clouds there, where it's kind of purple, we see about how much precipitation. We can just come right over here, and it's telling us in millimeters and in inches. And again, that's right there. We're looking at per hour. So we're seeing extreme amounts of precipitation falling per hour there. So you can do this seasonally. You can also do this monthly. So basically, when you do your time series, again, I just used my same longitude and then latitude. I said I want my final GPM data. And now I decided I want to look at every month, but I only want to look at it for 3 years. You can, as you see here, you can pick whichever months you want. Maybe you want to look at Januaries for the past 20 years and get a feel for how that amount of precipitation compared and contrasted for where you live, or where somebody else lives. Also, if you know of an extreme event that occurred, some drought, some flooding, some landslides, perhaps you want to take that location and go and find what that precipitation data looked like. So let's go ahead and see. This gets a little crazy. This is why we started off with a seasonal. Now what we have is we have a different colored line for every month. And in some places, you even have to go with different shapes because they're repeating the use of some of the colors. Basically, though, what you can see is that we had a lot of precipitation in July, particularly in July of 2018. And indeed, we did have a lot of flooding, and a lot of flooding in the Washington, D.C. area, which is not far from where I live. And you can, this is kind of neat because here we see for 2018, and over here our scale has changed again, depending on, how much precipitation is falling. Here we're looking at monthly versus looking at over the 3-month period. And I can see that in July of 2018, we had in just that 1 month period alone, almost 10 inches of precipitation fall. And as we saw earlier when we were looking at my rain gauge, I had over a ½ inch of rain that fell just in the last 24 hours here. So we're certainly getting a lot of precipitation, and I'll be fascinated to see if the month of April is different, say, going back in from 1990 to, from 1990 to 1995 to the present time. All right, so if you'd like to do this activity, and you are with a globe school, I have set up an activity where you're able to go in here and compare and contrast how much precipitation you found, or you can go on and do this using any data. You don't even have to be a globe school, that is within the globe program by using the data visualization tool. Go in there and compare and contrast how much precipitation the rain gauges found to how much precipitation the satellite found. You also can go to our precipitation education website and find all kinds of activities. There's an activity called Precipitation Towers, which takes some of that information I was showing you for different locations around the world and shows you how you can just use blocks or Legos to make a 3-dimensional bar graph of how much precipitation is falling. You could make those for your own location. We'd love to see them. Also, be sure to take a look at the GPM website. Get a feel for the precipitation measurement missions. Now it's the GPM website. And you can see the TRIM mission I was telling you about, Tropical Rainfall Measurement Mission, and the GPM mission, and learn all kinds of really interesting things about how and why we measure precipitation from space. Well, I hope you enjoyed this presentation, and I hope that you'll enjoy doing some NASA at home. Have a wonderful rest of your day.